All right, here we go. I'm starting part 2 of this amp build. So in part 1, we were deciding what parameters and what features we wanted for this amplifier. So it's a jazz tube amp. We wanted 10 to 15 watts with a 10-inch speaker, 1 tone control, 1 volume control, 1 gain. And we were trying to decide what preamp tubes and what output tubes we wanted to use based upon the configuration, based upon the output configuration that we choose. And that was going to be dictated by the power transformer. So how much power a transformer outputs that we choose. So here are the first 2 steps that we've gone through and the one we're going to do today. So detail the primary features and parameters, that's number 1. Then define the voltage and voltage requirements and tube selection. So that's what we're doing here. Now keep in mind, something I didn't mention in the other video was that these tubes all are supplied with the same voltage. So they all use the same voltage to power them. The first number in the series of the name of a tube constitutes how much filament voltage it needs. So 6.3 volts is all around, right? So that's going to be kind of the universal value. But what we needed to determine is how much current each of these tubes use. Now, if you remember, I was wanting to use a 6SN7 as my preamp tube, but I know that they use a little bit more than, say, a 12AX7, which is commonly used. But I'm also wanting to make this amp very small and very affordable, right? So that's why it's only 10 to 15 watts. So I'm trying to work with making it as simple as possible and making it most affordable and the least complex. So here, I've already started to detail all the parameters for these tubes and how much filament voltage they take. So using tubes in more or antique harmonic supply as my reference for where I'm going to get my power transformer and my output transformer. I've been using them as a supplier for years. They have reasonable prices. Again, to conserve time, I'm not going to scour the internet for looking for the cheapest thing. I don't know. You could go on Alibaba or something and try to find and import a cheaper transformer from China or something. But I'm just going to go with the mainstream providers. Hammond supplies great transformers for DIY projects and whatnot. You can even get replacement transformers from from production amplifiers, from name brand amplifiers, and use those as well from this side. You can get a replacement for a Fender reverb and retrofit it to your design if you'd like to do that. But here I found a Hammond transformer that's going to give me 2.5 amps for the filament supply, which is typical. If we get on this list, and this is why I wanted to show you, so if you go down this list, and you'll see that 2 amps to 2.5 amps is about the average. It'll go up to 3, sometimes even 4, 6, 8. This one has 8. That's a huge transformer. So these transformers, these are huge. This is something that you would use to maybe power something that had like a 100-watt amp or so. But if you go down the line, you'll see that most of these have 2 to 5. So 2 to 2.5 amps for the 6.3 volt filament. So that's what I'm going to use. The one I've decided on thus far has been the PT269EX, which has a 380 volt center tap at 71 milliamps, which will be important to us later. We're not going to look at that today. That's the high voltage. But for the filament, we have 6.3 at 2.5. So that's going to be, and that's $50. So that thing costs $50. I didn't put that in here. I think it actually could be more. Let's see. So we're trying to chart the cost as well. Yeah, so that's about $50. So, which isn't bad. 50. So this is our supply voltage. That's the voltage that we're going to be working with. Voltage that we're working with is the supply current. Sorry, the supply current is 2.5 amps. So if you look at the preamps, the preamp tubes that we're going to choose from is a 12AX7, but primarily what I really want to use is this 6SN7 here. It uses 0.6 amps, okay, so that's 600 milliamps, which is not bad, but as you can see, it's twice as much as a 12AX7, which is why I kind of want to do this, so you can kind of get the idea of why tubes like the 12AX7 and the 6 L6GC is used so commonly. It's because they're affordable and they supply a lot of gain and output, but they also have reasonable parameters to power them, right? So it doesn't take as much energy to power them, especially this 12AX. So 12AX in a sense is still a little bit more practical, but I really like the way these 6SN7 sound. I think they sound really great in a jazz setting as well. So I'm going to try to keep those in the design for now, and we'll go on. So we have 2.5 amps as a supply, with a 0.6 of that being used for one 6SN7. But keep in mind that I will probably use two 6SN7s for this amplifier. So the layout of it will be two preamp tubes and one output tube. So there's going to be two of these. So that would come out to 1.2. So we would do 2.5 minus 1.2, and that'll give us 1.3. So 1.3 amps left over. We can kind of just leave these as mock numbers here. Let's say 1.3 amps after preamp. So that's what's left over. So if we looked at our power output tubes in the list that we made up here in the first video, trying to discern, okay, which one should we use? Should we use a 6v6, or should we use a something and go single-ended and use a 6C33C, a KT88, a KT66, or a 6L6GC? Now these again are going in the order of the biggest to smallest, right? Now, if you look at this list, remember in the first video I said that the 6S or the 6C33C would be highly impractical, as you can see here, and not just because of the cost, but because of the filament requirement. It requires 3.2 to 6.6 amps of current just to power that one tube. So that is basically it will just be crossed off, you know. So that's just not feasible, because I would have to use another. I'd have to use another filament transformer, which would up the cost to have that tube in there. So that's pretty much knocked out. Now the KT88, $40, okay. But but it's 1.6 amps to power the KT88, which I only have 1.3 amps left over if I'm going to use two 6SN7s in the preamp section, which I'm pretty settled on doing that. So the KT88 is kind of off the mark as well. Now the KT66, it gives me, it's right at 1.3, so that could work. I am stretching it now. I'm using all of the 2.5, which is, I mean, it's not the worst thing in the world, but you kind of want to work your power transformer that hard, but it's possible. I mean, it's not something that hasn't been done before or anything like that. I'd like to leave room for at least, I don't know, 0.5 or at least even 1 amp. Ideally, maybe at least 1 amp under the supply voltage. If we go on, we see the 6L6GC is 0.9. 0.9, and that's only $17. Again, so these four choices would be if I would run single-ended. Now, these first two are obviously just off the mark because this one's obviously just way too high. It'd take 3 to 6 amps to power, so it's way too high. So that must just be crossed off, right? So the KT88 is also too high if I want to use these tubes. Now I could, if I went 12AX7, I could use the KT88, but the KT88 and the KT66 are very related. All these tubes are actually very related. And in fact, they're not only powered by just the 6.3 volts all around, but they're also interchangeable. They all have the same pinout, which is something I haven't mentioned yet. So a KT88, KT66, a 6L6GC, and a 6V6 all have the same pinout, so you can interchange them. Now that doesn't mean that they're going to all work the same in any kind of amplifier. You want to make sure that the specifications of the amplifier can handle that tube, but they all are interchangeable. Meaning that they all the pins match up. So why I mention that is theoretically I could design it around a KT66, but I could put a 6L6GC in there if I wanted to. Now, and this is going single-ended again. These are my single-ended choices, which actually seem to be fairly viable because you remember in the first video I said that would be a concern because single-ended transformers, these single-ended transformers are usually a bit pricier, but I had found on Tubes and More, Antique Electronic Supply, a replacement for a Fender Vibro King, reverb transformer that was reasonably priced. Now, it's a reverb transformer, mind you, but it's not technically an output transformer, but they're basically the same thing, and they could be used interchangeably. The frequency response isn't as good as maybe you'd like, but that's another topic entirely. So if we look here, so this is a single-ended. This is the average single-ended. So if I look, this is a single-ended 15-watt Hammond at the primary. These are the primary impedances, and the output is also selectable. So you can use different. It can go from 2 ohms to maybe 2 ohms to 8 ohms, depending on how you wire it. The primary is also the same way. So depending how you wire it, you can get a different impedance out of it, which is great. But that's $63, which is not terrible. But for a 15 watt, now if you look in comparison to a pull push 15 watt output transformer, it's about $20 less. You see, so there's a disparity. Remember I was talking about the disparity between, between a pull push output and a single-ended output. The pull push being cheaper because of the power transfer, or the output transformer. And as you can see, it's $20. That's $20 less, with exception of this single-ended transformer at 10 watts, which is really used as a reverb transformer, but it would work for the same effect in this scenario. It's only $33, so, which is awesome, and which is what I'm leaning towards right now. So now keep in mind here, it's just funny, that's one thing I wanted to show, is that we had in our minds that, okay, yeah, the single-ended is typically more expensive. And as I just showed you, yeah, it's usually at least $20 given just the output transformer. But the output tube could also cost more. But if you look at this list, you know, the 6L6GC is less than half the cost of a KT88, KT66. It's also substantially cheaper than a KT66. But if you look at the 6G6, which we might have used, it only takes 0.45 amps to power one 6V6, but we'd have to use two of them in a pull push configuration, remember. So that would actually come out to 0.9. So we would have, so to power one 6L6GC single-ended would take as much power to power two 6V6s in a pull push configuration. So even though you might be saving on the cost of the tube, because this is only $32. This is $32. It would take $32 for the pair of the 6V6s, and you'd spend almost half of that on just one 6L6GC. But of course, that cost would come back to you in the output transformer. Though, if I use this one that's highlighted, that's really a reverb transformer, as I mentioned earlier, and it's 5 watts less than the other two, but which is not a big deal. That's why I say 10 to 15 watts, and you see what's on the market, and you'll configure it to the market. That's just what you got to do at some point. So, design it around what's available. So, with the exception of this transformer, it actually became quite realistic to go single-ended, because this transformer is significantly cheaper than both of those. So I mean, we've just, I guess, lucked out on that one. So at this point, we could say that we want to use two 6SN7s for the preamp section. And yeah, we're actually going to go single-ended and use a KT66 or 6L6GC, because remember, we don't actually have to choose between them. Now I might design it and tailor it towards the KT66, even though it's pushing the limitation of my power transformer, because my power transformer only supplies 2.5 amps, and I'll be pushing all the way up to 2.5 amps. But I could also, nothing holds me back from using that 6L6GC in there as well. So that 6L6GC and that KT88, the KT66 can be interchangeable. So yeah, so that's progress there. So what we've decided is now we have our parameters from 5 on to 6. So we know now that we can use these the 6 SN7s, and that's going to take up 1.2 amps of our filament current, and the KT66 will take up, let me see if I can remember, 1.3, and the 6L6GC will take up 0.9. So this gives me a much better and a much clearer idea of what the configuration will be. So now I can even go down here and just write the tube configuration will be 6SN7, 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 KT66. And it'll have, I can even go further and say that it'll have an 8 ohm output, it'll have an 8 ohm output. What else will it have? So it'll have 3 tubes at 8 ohm output. The output will be interchangeable with a 6L6 GC. I think that's pretty much it, and that leaves us at a good space for now. Yeah, so going on to the next phase, what I would do is start sketching out how I'd want the amp to be designed. So I'd start designing the circuit for the preamp and the circuit for the tone control and the volume control and the gain. Now that we know what our voltages are, I know that I'm going to be having a power transformer that has a 380 volt center tap at 71 milliamps with a 6.3 volt tap at 2.5, which works out for us. This works out. Now later on, the next thing to figure out is if this 7.1 milliamps is enough current to actually power the KT66 or the 6L6GC, which off the top of my head, I think it should be fine. It shouldn't be a problem, but that'll be the next variable to take into account. Now, I don't know if anybody's familiar with building tube amplifiers and the average voltages. One could say that 380 volts, especially center tapped, would be low, because if that's center tapped, then that's really actually only giving you half of that voltage. So if we took 380 and divided that, if we're going half wave, and that's only 190. But I'll probably use a full wave rectifier if I'm going to use that transformer, which I plan to use a solid state, so there's nothing wrong with just using a solid state full bridge rectifier, and that'll give me the 380, which will probably go up to 450 after it's rectified, close to probably 435 or so after it's rectified and filtered. So yeah, that's part 2 of designing these amplifiers. Again, so just as a recap, figured out the parameters of it, what I wanted it to do. Now we figured out what tubes to use based upon the voltages that came from the most practical power transformer to use. So it just comes to find that Going single-ended actually turned out to be the most affordable. If I go with this, we'll go with this transformer and use a 6L6 GC and interchange it and go between the 6L6 and the KT66. Everything should work out good. So again, at the next phase, what I'm going to be worried about is checking out the amperage requirements to power the plate of a KT66 and the 6L6 GC. After I do that, then I'll start sketching out the actual schematic and what I want that to look like. So, all right, there you have it. There's part 2. See you soon.